I will repair this mini split air conditioner circuit board in this video. It has already been tried to be fixed by another repairman, but he couldn't repair it, and I will try to repair it. My procedure is that I first of all check the circuit board physically. As it has come from the hands of another repairman, I will check whether any component from the circuit board is missing or not. The diode has been desoldered and again soldered back into the circuit board. The IGBT in the circuit board is missing. Let's check what the fault is in this circuit board. I will not pass direct electricity to the circuit board because, as you know, someone else has already tried to repair it. I will do the physical test of the circuit board first. First of all, I will check the fuse with a multimeter on continuity mode. It is fine, and this is the main fuse of this circuit board. This fuse could be of 15 to 20 amperes. Other than this one, another fuse is also installed in this circuit board, which is used for the SMPS of this circuit board. So, let's check it as well. This is a smaller fuse. This is of 3.15 amperes. I will place the multimeter probes to check this fuse. This fuse is also fine. This means there would be no problem in the SMPS of this circuit board because the fuse is fine. This means that the high side of this circuit board is problematic. I will now test the bridge rectifier of this circuit board. I am moving on step by step to test this circuit board. This diode of the rectifier is fine. The second diode is also fine. The third diode is also fine, as all the diodes of the rectifier are fine, which means that the bridge rectifier is also okay. A diode is installed here. Let's check it as well. The value from anode to cathode is fine. Now, I will change the polarity of the probes to check whether it has any leakage or not. The diode is also fine. Next, I will check the IPM of this circuit board. These are the negative pins. This is the positive, and these are the U, V, and W pins. First, I will put the positive and negative probes with the same positive and negative pins of the IPM. The voltage drop on the multimeter is shown as 0.027 volts on these pins of the IPM. This means these pins are short-circuited. I will now check the next pin. The pin shows 0 voltage drop with the positive pin of the IPM. The next pin shows 0.480 voltage drop. This means the one pin between the UVW pins is short-circuited. The negative pins are also short-circuited. I will replace this IPM with a new one, and then let's see what happens after changing the IPM. The circuit board works or not. Before changing the capacitor, I will test the power capacitors of the circuit board on continuity mode. They are already discharged. Before shooting the video, I discharged them. It's important to discharge the capacitors before testing them, to prevent your multimeter from being damaged and also to prevent yourself from being electrocuted. The capacitors seem to be fine. These capacitors are fine. I will now remove the IPM from this circuit board. I will add a new solder to the pins of the IPM. Adding new solder makes the old solder softer, which makes the removal of the IPM easy. This is the IPM. I have removed it from the circuit board. FNA 41060B2 is the number of this IPM. I will clean the holes of the IPM traces and then install the new one. I will test this IPM to confirm whether it is bad or not. I will put the negative probe on the positive pin and the positive probe on the negative pin of the IPM. It shows a 0.880 voltage drop. I will check the next pin. The one pin among the U, V, and W pins is short-circuited. I will test the next pin, which is fine. The last pin is also fine. The one pin of the IPM is short-circuited. I will install this new IPM in the circuit board. This is plastic, which is used to place a gap between the IPM and the circuit board. I have installed the plastic. I will now install the IPM on top of it. I have already aligned the IPM with the traces. I have easily put it in the holes of its traces. It has been fitted inside from one side of the circuit board because I had already aligned the IPM pins according to their traces inside the circuit board. Just to show you, I am installing it on the circuit board. It has been fitted in its traces. Attach it with the plastic. We don't need to place the heat sink on top for soldering because the plastic piece is beneath it. I will solder the pins of the IPM, but before that, put soldering paste on the pins of the IPM. The paste melts the solder very nicely. I have put paste on all the pins of the IPM for clean soldering on the pins. So, let's start doing the soldering. I have crooked the pins on the corner of the IPM already to prevent the IPM from falling down. I will add solder to one pin of the IPM. I will push the IPM upward to prevent the gap between the IPM and the plastic piece. I will now solder one of the pins on the opposite sides of the IPM. This will prevent the IPM from moving from its place. I will straighten this pin and solder it. I will straighten this pin as well. These pins are attached together. I have soldered them as well. After this, clean the pins you soldered to prevent the pins from being joined together. First, I have cleaned them with a brush. I will now put the scraper between the gaps of the pins to check that no pins are soldered together. The IPM and I have also installed a new IGBT in the circuit board. I will power on the circuit board now. Let's see if it works or not. The light of the circuit board has started to flash. And if we check the voltages, the 12 volts are to power on this relay. They are passing in the circuit board. Other than this, 5 and 15 volts should be passing through the circuit board. The 5 volts are passing because the microcontroller has turned on. I will check the voltages on the IPM. 309 volts are passing through these pins of the IPM. The next is the 15 volts. Let's check that 15 volts pass through the next IPM pin. And see this, 15 volts were available here. They came across this pin and are gone. The IPM has stopped working. Oops, my bad. I am checking on the wrong pins. As these are positive voltages, we need to check the negative pin. 15 volts are on the first pin. 15 volts are passing through the next pin as well. 15 volts are also on the third pin. This circuit board has been fixed, and it will be further tested inside the unit. Click on the left or right thumbnail to watch the next videos. And subscribe. Thank you.